Everyone, I am Professor Sri. Welcome to the session on aircraft, wood, and plywood. If you want to learn more about engineering and management stuff, subscribe to the channel Professor Srinidhi Kukila. Aircraft, wood, and plywood. So, in this session, we are going to discuss introduction to wood, wood structure, cutting and seasoning of wood, diseases and defects, joining process, plywood, structural characteristics of plywood and types of plywood. From the very beginning of aviation wood, it has been used in aircraft construction. Early aircraft designers and builders often used ash and hickory. They were looking for a type of wood that would be relatively lightweight in addition to being very strong. Just prior to World War One, Sitka spruce was discovered by aircraft builders and found to be very well suited to their needs. The strength to weight ratio was discovered to be very favorable for aircraft use. Several other types of wood had similar strength to weight ratios but were not as easily harvested or as plentiful. At the time, spruce proved to be the best choice, not only because of the physical characteristics, but of equal importance was the fact that spruce was readily available and easy to use as a building material. With the advantages noted, spruce became very widely accepted as the primary material to be used in building an airplane. With the advent of World War II, spruce became even more popular. Manufacturers used the material in the construction of a large number of aircraft. Wooden spars were fabricated from spruce in many airplanes along with the ribs and other structural parts. Because of high demand for both aircraft production and for spruce to be used as major material in manufacturing parts, forests of this popular wood were rapidly depleted. The use of Sitka spruce was carried into post-war construction in many aircraft. The maintenance and restoration processes of existing aircraft required a large supply of wood. Wood was a popular choice for aircraft construction because of its advantageous strength to weight ratio, workability, abundance, and low cost. The largest plane ever constructed, the Spruce Goose, is largely comprised of spruce. During this time in aviation history, spruce was cheaper than aluminum or steel. Today, spruce and other types of wood remain somewhat popular for aircraft construction. Many aircraft designers and kit manufacturers within the aviation industry use wood as primary structure. If wood is not the primary structure, it is almost sure to be found in some component parts. Wood is not as strong as steel or aluminum, however, the construction can be so designed that the necessary strength is achieved with corresponding savings in weight. Many designers prefer to use wooden spars in acrobatic aircraft because the wood will better withstand the bending loads imposed during acrobatics. Unlike metal, wood does not weaken from fatigue. This, of course, is an advantage to the aircraft builder. Wood is used in fabricating spars, building ribs, floorboards, instrument panels, wingtip bows, longerons, and stringers, leading edges, etc. Wood is easily formed into shapes, making it obvious choice for wingtip bows, leading edges, and wing walkways. Woodworking is a skill that is easily learned by the novice who usually has a basic knowledge of wood construction and some of the necessary tools. Safety hazards are very evident, unlike some of the other types of aircraft construction. You should also understand that making mistakes with wood could be costly. You cannot easily repair a piece of wood cut to the wrong dimension. Wood is used throughout the world for a wide variety of purposes. It is stronger for its weight than any other material, excepting certain alloy steels. Timber is readily worked by hand using simple tools and is therefore far cheaper to use than metal. To appreciate the use of timber in aircraft construction, it is necessary to learn something about the growth and structure of wood. There are two types of tree: the conifer or evergreen and the deciduous. A conifer tree is distinguished by its needle like leaves. Its seeds are formed in the familiar cone shaped pod. For a conifer, softwood is obtained. A deciduous tree has broad, flat leaves which it sheds in the autumn. Its seeds are enclosed in ordinary cases like oak tree, birch, walnut, and many more. Timber from deciduous trees is said to be hardwood. So it can be seen, therefore, that the terms softwood and hardwood apply to the family or type of tree and do not necessarily indicate the density of the wood. Both hardwood and softwood trees are said to be exogenous. An exogenous tree is one whose growth progresses toward outwards from the core or heart by the development of additional rings or layers of wood. Certain trees are exceptions to this rule, like bamboo and palm. So these wood is unsuitable for aircraft construction. Exogenous trees grow for only part of the year. Having remained dormant during the winter, the spring breaks the rising of the sap. The roots absorb moistures and minerals from the soil, and this fluid flow up the tree underneath the bark to the leaves. The rising of the sap develops the first half layer of a new annual growth rings. At the close of the summer, when the sap descends, further growth results. This latter outer portion of the annual ring, termed autumn wood, is readily distinguishable from spring wood as it is somewhat lighter in color. If a fully developed tree is sectioned, examination will reveal three obviously different types of growth. These comprise the core or pith, the annual rings, and the bark. The pith is the soft center of the trunk and is the oldest part of the tree. Annual rings represent the principal portion of the tree. The bark is the outer covering of the tree and is composed of two layers separated from the outer annual ring by the cambium, a skin like tissue which is pale yellow or cream in color. The inner part of the woody layers or autumn rings is known as heartwood. In a healthy tree, it is dark in color. The outer part of the woody layer is ripe and is termed sapwood. It is porous and full of sap. This moisture causes it to be lighter in color than hardwood. Sapwood has very little strength. The sap it contains is composed to a large extent of a sugary substance which hastens decay and furthermore invites attack by insects. The bark is a cork like material The outer layer hard and inner layer known as the bast soft. Directly under the bast is the cambium, which is the source of growth. The rising and descending sap develops the skin into a new ring each year, thereby forming a new cambium for the following year's growth. The importance of this tissue is shown by the fact that a sure way to kill a tree is to remove a 2-inch wide strip of bark from around the trunk and sever the cambium. The tree will die at the next movement of the sap. The most active period of growth is during the spring. The wood produces the wood produced is light in color and of open texture. As autumn approaches, the cambium becomes less active and growth becomes darker in color and denser in texture. The difference between spring and autumn growth is more pronounced in some species of the trees than in the other. Firs and pines show the growth clearly. In teak and mahogany, the spring and autumn growths are barely distinguishable. To enable moisture to pass from sapwood to the heartwood during growth, thin sheets of cellular tissue extend rapidly from pith towards the bark and continue lengthways throughout the timber. These are known as medullary rays, and those which extend from pith to bark are termed primary rays, while those which radiate only part of the way are called secondary rays. Medullary rays are present in all exogenous trees. In oak and beech, they are very numerous and are closely spaced. This concludes briefly the structure of timber. Next, the next stage is to consider the cutting and seasoning of wood. Cutting and seasoning trees are normally felled at a period when the sap is at rest. Any other time results in the timber containing an excess of sap which is difficult to dry out without adversely affecting the durability of the wood. To obtain the best results, a tree should be felled when mature. Immature trees and old trees produce inferior quality wood which is neither strong nor durable. A felled tree is termed a log, from which may be obtained timber in various usage sizes. The process of cutting up a log is known as conversion. There are 6 standard terms of reference for timber that has been converted, which are used to define certain sizes. They are plank, which is 2-inch to 4-inch thick and 11-inch and over in width. Deal, 2-inch to 4-inch thick by 9-inch to 10-inch in width. Batten, 2-inch to 4-inch thick by 5 to 8-inch in width. Next one, that is fourth one, scantling, 2 to 4-inch thick by 2 to 4 feet 2-inch in width. Fifth one, bold, which is under 2-inch thick and by 4 and over in width. Last one, strip, under 2-inch thick and under 4-inch in width. The wood, when cut, tends to warp and twist by virtue of shrinkage as it dries out. This distortion is due to shrinkage or contraction along the lines or arcs of annual rings. Timber for aircraft use is converted in such a manner as to reduce the effect of shrinkage and to eliminate as far as possible warp in service. Wood cut in this manner is known as rift sawn and is easily distinguishable by the fact that it is cut with the direction of the anvil rings at right angle to its surface. In other words, parallel to its thickness. Broadly speaking, rift sawing is not the most economical method of converting timber. There is necessarily a high percentage of wastage in the shape of odd strips. However, as all the wood produced is usable without fear of warping, it is better proposition to cut in this manner. Even if a tree is cut in winter when the sap is dormant, the wood will still contain a high percentage of moisture, most of which must be removed before it can be used for aircraft or indeed any other form of structural work. Seasoning of wood. The drying out process is termed as seasoning. When seasoned, timber becomes harder, stiffer, and has an increased resistance to decay. The presence of sap invites decay and disease. Furthermore, seasoned timber is still less likely to warp or shrink in service. If all the moisture present in wood is removed, the timber will become excessively hard and brittle. Therefore, it is important to allow a percentage of moisture to remain in the wood to keep it supple and to certain extent resilient. The amount of seasoning is measured by the quantity of moisture left in the wood afterwards and is expressed as percentage moisture content of the timber if it were to be thoroughly dried out. The optimum moisture content of aircraft timber is about 15%. Timber may be seasoned in several ways. One method is to stack the timber under cover in the open to allow free passage of air through the pile. This method produces well seasoned wood, but depending on the size of the timber and whether it is hardwood or softwood, it takes from 1 year to 10 years to complete. A second method is to float the log before conversion in a stream of fresh running water and allow the sap to be washed out as the water flows through the pores of the timber. This process takes about 10 days, after which the logs are allowed to dry out. The water evaporates more quickly than the sap would. After conversion, the timber is naturally seasoned by the first process described above, seasoning being completed in about half the normal time. The drawback about water seasoning is that although speedy in action, it is likely to affect the durability of the timber. Finally, the third method is the most widely used method for engineering timber and is now used exclusively in aircraft woods. This consists of drying the timber by means of hot air in a kiln. Boards can be seasoned by this manner in about 2 weeks. Kiln drying consists of stacking the converted timber in a chamber in which the temperature is maintained between 80 to 220 Fahrenheit according to the species of timber being processed. The heat is provided by means of steam pipes. There are two types of kilns. First, there is the compartment type where a charge of timber is placed in a chamber and remains there until the seasoning is complete. Secondly, there is the progressive kiln in which the timber is stacked on trucks and moved slowly through the whole length of the tunnel operation. This type of kiln can always be kept full charged with wood for, for as the seasoned timber is withdrawn from one end. Fresh timber for processing can be put in at the other end. Diseases and defects. As with all living things, trees are subject to natural diseases and defects during growth, which can have very serious effect on the strength of resulting timber. Also, converted timber can develop disease which render it useless. Diseases of timber are caused by the action of fungi. A fungus is a life form of vegetation which can only live by feeding on organic substances. It contains minute thread-like cells which penetrate the wood and absorb substances of cellular tissue as food. This process breaks up the whole structure of timber and can be identified by obvious mold on the surface, a fine cobweb-like mold, discoloration in patches, and in advanced stages, the rendering of timber into a useless, spongy mass. The list in the screen are the principal diseases and natural defects which may occur in timber. Dry rot, which cannot occur in living wood but attacks wood exposed to warm, moist conditions combined with poor ventilation. Sapwood and unseasoned timber are especially susceptible to this. The disease spread very rapidly and is detected by the fungus growth which develops on the surface. Ultimately, the wood is reduced to a powder. Wet rot. It may occur in both living trees and converted timbers. It is a decomposition of the woody fibers brought about by water entering through the bark into the circulation of the sap. Converted timber exposed to alternate wet and dry conditions will contract this disease, which transforms the wood into a soft, spongy mass. Ruxiness, which is similar to wet rot, but in this case the water becomes stagnant in the timber and sets up decomposition of the surrounding fiber structure. Dote. It is a fungus growth which may be present in unseasoned timber and remain alive when the wood is seasoned. It is recognized as a stain or just a speckled area on the wood and is a serious disease which spreads very rapidly through the timber, destroying the fiber structure and rendering the timber a useless mass. Dote affects spruce in particular, and if discovered, the affected timber must be burnt. Since dote is very virulent growth, timber in contact with an infected piece will also contract it and should be burned likewise. In early stages, it should be remembered that the spores are invisible to the naked eye. Foxiness. It affects the fibrous structure of over mature trees. It is a form of rot which is discernible and converted timber of a reddish brown stain. Rind galls. They are lumpy swellings on the trunks or branches of trees. They are caused by the growth of new layers over wound made either by attack of insects or by a branch being broken off. Rind galls reduce the strength of the affected area as they induce divergence of the grain. Rami grain. It is the term given to wood with curly grain. This is caused by faulty and irregular growth. Rami grain wood is difficult to work and is weak, therefore, it is unsuitable for structural purposes. Cross grain. It is okay. It is occasioned by a bend in tree or due to a branch causing grain divergence. It can also be induced by faulty conversion. Limits are laid down as to the amount of grain runout and the maximum acceptable is 1 in 15. Inclination of fibers to any edge is a serious defect. For highly stressed pieces such as longerons and spars, the recommended grain runout should not be less than 1 in 25. Spiral grain. It is similar to cross grain and is caused by high winds twisting the trunk. The same requirements as for cross grain apply here. In addition to these diseases and defects, timber is also subject to attack by insects. Certain beetles bore into the wood and deposit their larvae. Their presence detected by a number of small holes in the surface. Ants also devour the wood, in particular the white ant. Timber that has been subjected to insect attack in my way must be rejected as unfit for use. Next, splits or cracks. They are lengthwise separations of wood and are caused by the tearing apart of the wood cells. Normally, they follow the direction of the grain and are usually caused by excessive stresses set up in wood by shrinkage due to changes in the moisture content. This is especially evident in cases where boards are stored with one end exposed to heat weather. Knots. They are caused by the growth of branches. In growth, they may be prevented by removal of buds as they form. There are many different types of knot, among which are the following: sound knot, loose knot, pith knot, encased knot, rotten knot, pin knot luster, standard knot, and spike knot. In all the cases, a knot means the divergence of the grain. Allowable knots are detailed further on. Pitch pockets or resin ducts. They are openings in the wood between the annual rings filled with the resin, since they do not interfere to any great extent with the rain direction. Small resin ducts may be permissible as long as grain divergence is not appreciable. Even in high stressed pieces, the presence of resin ducts provided that they are not near the outer faces need not necessitate scrapping of the piece. However, in hot conditions, the resin may melt and flow out, locally destroying any protective finish and exposing the bare wood. Furthermore, the resin severely impedes the successful gluing. Some of the woods used in aircraft constructions. There are four woods which are regularly used in aircraft constructions. They are Sitka spruce, birch, ash, and Douglas fir. In addition, mahogany, balsa, pine, and gabon fulfill certain duties. Sitka spruce is a softwood which grows in Canada and the United States of America. It is brownish yellow in color, straight green, and satiny in appearance. Its qualities regarding resistance is splitting, bending, and stiffness are very good in relation to its weight. Due to this favorable strength to weight ratio, it is used extensively in aircraft construction of spars, longerons, and many more. Birch. It is a hardwood and grows in most parts of Europe. It is yellowish white or brownish white, strong, and does not split easily. It is sometimes used in place of ash for laminated members such as wingtip posts, in addition to being used for bearing blocks. Its principal use in aircraft, however, is for the manufacture of plywood. Ash. It is a hardwood which grows in England. It is yellow white or yellow brown in color and is close green. It is tough and has good shock resisting qualities. Ash is used for longerons, bearing blocks, laminated bows, glider skates, and keel members and other parts where strength and toughness is prerequisite. Dollar's fir. Dollar's fir is a softwood grown in Canada and the USA. Its color varies from reddish brown to orange brown and it has prominent growth rings. Douglas fir is often used in place of spruce for its strength properties are very similar. It is, however, somewhat heavier. The wood is straight green and somewhat resinous, giving rise to a distinctive odor when worked. Mahogany is a hardwood grown in Honduras and Central America and in rest of the world. It is reddish brown to dull red in color with straight close grain. It has good bending strength combined with stiffness and along the grain. It will withstand compressive loads very well. Properly, if properly seasoned, it will not warp or shrink and retain glue exceptionally well. It is used for bearing blocks, taking compressive loads and propellers. On account of its extreme resistance to warping, it is used for rigging boards and trestle beams in industries. Balsa. Although very soft and low in strength properties, it is hardwood. It is the lightest timber in general use and is pinkish white to pale brown in color. Due to its porosity, if it is badly stored or inadequately protected in use, it is very readily deteriorates if exposed to moisture. Its principal uses in aircraft construction are the making of fairings, fillets, and light, low density contour blocks. It is also used as the core or manufacture of soundproof plywood. Pine, better known as Oregon pine in American continent, is very similar to spruce and fulfills similar duties. It is slightly heavier than spruce but lighter than Dollars fir. Gabon. It is a tropical wood of the mahogany family. It is light open green and fibrous. It is used in manufacture of plywood for aircraft use in place of birch. The main advantage of Gabon ply is that a thicker and more stable ply skin may be used for the same weight as a somewhat thinner skin of birch ply. Due to the porosity of Gabon plywood, it is necessary to cover the ply skin structure with Metapolam fabric to provide a suitable base for a good paint finish. Noble fir. It has satisfactory characteristics with regard to workability, warping, splitting, and gluing. It may be used as direct substitute for spruce in the same sizes provided that the shear stresses do not become critical. It is somewhat softer in texture than spruce. Western hemlock. It has a less uniform texture as compared with spruce and requires careful selection. Otherwise, it is satisfactory. White pine. It has excellent working qualities and is uniform in properties, but is somewhat low in hardness and shock resisting capacity. Cannot be used as spruce substitute without increase in size to compensate for lower strength. White cedar or Port Orford can be used as a direct substitute for spruce in the same sizes or slightly less, provided that such reductions are sustainable. Can only be glued satisfactorily with synthetic resin adhesives. For light aircraft, wood has never lost its usefulness, and certainly in American and European continent, steel has never usurped timber. The development of synthetic resin glues has revolutionized wood aircraft construction. Adhesives are now available in the construction which have excellent moisture resistant qualities in addition to providing a bond between surfaces, which in past years would have been considered impossible. Joints are no longer weak links in the chain. Laminated woods have ceased to be questionable stress wise. Wood fiber can now be laid in direction required for maximum strength, and a wide choice of different timbers of varying properties has made the design of a homogeneous practical wood structure not just an interesting possibility but a reality. Aircraft joining process for wood. Joints, they are methods of cutting wood to increase the strength of joints. All joints are generally fixed with wood adhesives. So joining process, there are many different types of joints. First one, basic butt joint. Second one, mitered butt joint, half lap joint, tongue and groove joint, mortise and tenon joint, biscuit joint, pocket joint, dado joint, rabbet joint, through dovetail joint, half blind dovetail joint, sliding dovetail joint, and box joint. First one, basic butt joint. There is no more basic wood joinery than the butt joint. A butt joint is nothing more than when one piece of wood butts into another, most often at a right angle or square to the other board, and is fastened using mechanical fasteners. This type of joint is often used in wall framing on construction sites. Second one, mitered butt joint. A mitered butt joint is nearly the same as a basic butt joint, except that two boards are joined at an angle instead of square to one another. The advantage of that is the mitered butt joint will not show any end grain and as such is a bit more aesthetically pleasing. However, the mitered butt joint isn't all that strong. Half lap joint. A half lap joint is where half of each of the two boards being joined is removed so that two boards join together flush with one another. This type of wood joinery can obviously weaken the strength of the two adjoining boards but also is a stronger joint than butt joint. There are a number of projects where this type of wood joint is quite desirable in spite of its drawbacks. Tongue and groove joint. When joining two boards square to one another along a long edge, one can simply butt the joint together and hold it with fasteners. However, the tongue and groove joint is much stronger and provide more adjoining surface areas, which is particularly useful if you're going to glue the joint. Mortise and tenon joint. The mortise and tenon is a classic wood joinery method. These joints have been used since the early times of woodworking and are still among the strongest and most elegant methods of joining wood. Biscuit joint. Another method of joining boards along the edges like tongue and groove joint is to cut slots and use beechwood wafers known as biscuits to hold the boards in place. This is a very useful modern woodworking joint, particularly for creating tabletops, rely on glue and rely on glue and swelling of the beechwood biscuit to hold the boards in place. Pocket joint. The pocket joint is a type of wood joinery that involves cutting a slot and pre-drilling a pilot hole at an angle between two boards before connecting the two with a screw. This drilling needs to be very accurate, so it is typically accomplished by use of a commercial jig. Pocket joints work greatly for cabinet face frames and other similar applications where a lot of strength is not needed. Dado joints. A dado is nothing more than a square grooved slot on one board where another board will fit. Similar to tongue and groove joinery, this is a commonly used wood joint for connecting plywood, such as building cabinetry. Rabbet joint. Another common wood joint used in cabinetry is the rabbet joint. A rabbet is essentially a dado cut along the edge of a board. Rabbets are often used at the back of cabinets and other similar assemblies for attaching the back to the sides of the box, adding a considerable amount of strength to the assembly. Through dovetail joint. Of all wood joinery methods, the through dovetail may be the most revered. A classic through dovetail is beautiful and very strong and adds a touch of class to any piece. There are a few methods for creating through dovetails, from hand cutting to machining with a jig. Half blind dovetail joint. There are situations where a dovetail joins in connection to of choice, but both edges of dovetail should not be visible. A perfect example is a drawer front where you don't want to see the ends of through dovetail or the face of the drawer. For this type of joint, the best choice is a half blind dovetail. Sliding dovetail joint is a versatile joint with a lot of possible uses. A good way to think of it is as a locking dado. Box joint. Dovetail joints are beautiful and strong but not always practical. A box joint is a simpler alternative to the dovetail joint. Next is plywood. Plywood. Plywood is a manufactured wood panel made from thin sheets of wood veneer. Plywood layers, also called as veneer or plies, are glued together with adjacent plies having their wood grain rotated relative to adjacent layers up to 90 degrees. All plywoods bind resin and wood fiber sheets to form a composite material. This alternation of grain is called cross graining and has several important benefits, like it reduces the tendency of wood to split when nailed at the edges, it reduces expansion and shrinkage, providing improved dimensional stability, and it makes the strength of the panel consistent across all directions. There is usually an odd number of plies so that the sheet is balanced. This reduces warping. Because plywood is bonded with grains running against one another and with an odd number of composite parts, it is very hard to bend it perpendicular to the grain direction of the surface ply. Plywood was invented in the 19th century by Emmanuel Nobel, surprisingly, father of Alfred Nobel. So, Emmanuel Nobel realized that several thinner layers of wood bonded together would be stronger than one single thick layer of wood and invented the rotary lathe used in plywood manufacturing. Structural characteristics. A typical plywood panel has face veneers of a higher grade than the core veneer. The principal function of core layers is to increase the separation between outer layers where the bending stresses are highest, thus increasing the panel's resistance to bending. As a result, thicker panels can span greater distances under the same loads. In bending, maximum stress occurs in the outermost layer. One in tension, the other is compression. Bending stress decreases from the maximum at the face layers to nearly zero at the central layer. Shear stress, by contrast, is higher in the center of the panel and zero at the outer fibers. Different varieties of plywood exist for different applications. Softwood plywood. It is usually made either of cedar, Douglas fir, or spruce, pine, and fir, collectively known as spruce pine fir or SPF plywood, or redwood, and is typically used for construction and industrial purposes. Plywood for flooring applications is often tongue and groove. This prevents one board from moving up or down relatively to its neighbor, providing a solid feeling flow when the joints do not lie over joints. Hardwood plywood. It is made out of wood from decot trees like oak, beech, mahogany, and used to demanding end users. Hardwood plywood is characterized by its excellent strength, stiffness, and resilience to creep. It has a high planar shear strength and impact resistance, which makes it especially suitable for heavy duty floor and wall structures. Oriented plywood construction has a high wheel carrying capacity. Hardwood plywood has excellent surface hardness and damage and wear resistance. Tropical plywood. It is made of mixed species of tropical timber. Originally from Asian region, it is now also manufactured in African and American countries. Tropical plywood is superior to softwood plywood due to its density, strength, evenness of layers, and high quality. It is usually sold at premium in many markets if manufactured with high standards. Tropical plywood is widely used in UK, Japan, USA, Taiwan, Korea, Dubai, and other countries worldwide. It is used for construction purposes in many regions due to its low cost. However, many countries' forests have been over-harvested, including the Philippines, Malaysia, Indonesia, largely due to the demand of plywood production and exports. Aircraft plywood. High strength plywood, also known as aircraft plywood, is made from mahogany, spruce, birch, using adhesives with an increased resistance to heat and humidity. It is used in construction of air assault gliders during the time of World War II and also several fighter aircraft, most notably the multi-role British Mosquito, nicknamed the Wooden Wonder. Plywood was used for wing surfaces and also flat sections such as bulkheads and the webs of the wing spar. The fuselage had exceptional rigidity from bonded ply balsa ply sandwich of its monocoque shell. Elliptical in cross section, it was formed in two separate mirror image halves using curved molds. Structural aircraft grade plywood is most commonly manufactured from African mahogany, spruce, or birch veneers that are bonded together in a hot press over hardwood cores of basswood or poplar or from European birch veneers throughout. Basswood is another type of aviation grade plywood that is lighter and more flexible than mahogany and birch plywood but has slightly less structural strength. Aviation grade plywood is manufactured to a number of specifications include those outlined since 1930s for surveying and testing of plywoods of aircraft, the latter of which calls for shear testing after immersion in boiling water for 3 hours to verify the adhesive qualities between plies and meets specifications. Howard Hughes H4 Hercules was constructed of plywood. The plane was built by Hughes Aircraft Company employed a plywood and resin duramold process. The specialized wood veneer was made by Rodis Manufacturing in Marshfield, Wisconsin. Next is overlaid plywood. Decorative plywood, usually faced with hardwood including ash, oak, red oak, birch, maple, mahogany, Philippines, Philippine mahogany, often called yawan, yawn, or meranti, and having no relation to true mahogany, then rosewood, teak, and a large number of other hardwood. Flexible plywood. It is designed for making curved parts a practice which dates back to the 1850s in furniture making. Aircraft grade plywood, often Baltic birch, is made from 3 or more plies of birch. In UK, single ply shades of veneer were used to make stovepipe hats in Victorian times. So flexible modern plywood is sometimes known there as hatter's ply. Although the original material was not strictly plywood but a single sheet of veneer. Marine plywood. Marine plywood is manufactured from durable face and core veneers with few defects, so it performs longer in both humid and wet conditions and resists delaminating and fungal attack. Its construction is such that it can be used in environments where it is exposed to moisture for long periods. Each wood veneer will be from tropical hardwood, have negligible core gap, limiting the chance of trapping water in the plywood and hence providing a solid and stable glue bond. It uses an exterior weather and boil proof glue similar to most exterior plywood. Some of the other plywoods, including fire retardant, moisture resistant, wire mesh, sign grade, and pressure treated. However, the plywood may be treated with various chemicals to improve the plywood's fireproofing. Each of these products is designed to fill a need in industry. Baltic birch plywood is a product of an area around the Baltic Sea, originally manufactured by European cabinet makers but now popular in United States as well. It is very stable, composed of an inner void-free core of cross-band birch plies with an exterior grade adhesives. The face veneers are thicker than traditional cabinet grade plywood. So this is the end of the session on aircraft wood and plywoods. So under woods we have discussed what is wood, different structural components of wood, then uh, different types and classifications of wood, and then we have studied seasoning of wood, cutting of wood, seasoning of wood, the three methods for seasoning of wood. Then we have discussed about some of the natural diseases and defects grown by the wood, and then we have studied about the different types of wood used in aircraft and other applications. And then we have come to plywoods, what is plywood, and different types of plywood, its structural characteristics. And this is the end of the session on aircraft wood and plywood. If you want to learn more about engineering and management concepts, subscribe to the channel Professor Srinidhi Kukila. Thank you.